multiplication. So what we'll be doing here will be log base 10 into bracket 2x plus 1 all over 3x minus 2 is equals to 1. We'll now find the index form of this. That will be 2x plus 1 all over 3x minus 2 is equals to 10 raised to power 1. 10 raised to power 1, which is our index form of this logarithm. So from here we'll now expand and then we'll cross multiply. Remember that 10 raised to power 1 is 10, which is equals to 10. So we'll now cross multiply. By the time we cross multiply, we'll be having 2x plus 1 is equals to 10 into brackets of 3x minus 2. We'll now be having is equals to 2x plus 1 is equals to 30x minus 20. Now is equals to, we'll be taking this 2 to this side and bringing this 20 to this side. So that will be 1 plus, by the time this minus 20 is crossing the equal to sign, it will become plus. That will be plus 20. By the time this 2 plus 2x is crossing, it will become minus. So that will be 30x minus 2x. Now what we are going to do, we have already is equals to, we'll just add this. 1 plus 20 will give us 1 plus 20 will give us 21. Then on the right hand side, 30x minus 2x will give us 28x. 28x. Dividing both sides by 28, we'll be having 21 all over 28 is equals to 28x all over 28. This 28 will cancel this 28. Now, we'll divide by 7. That will be 3 all over 4 is equals to x. Therefore, x is equals to what? 3 all over 4, which is the final answer. Example number 4. Simplify log 9 minus log 4 all over log 3 minus log 2. This is just simple arithmetic. That would be log 3 squared minus log 2 squared all over log 3 minus log 2, which is equals to, these two, we bring it to this side. That will be 2 log 3 minus this power, we bring it down, 2 log 2 all over log 3 minus log 2. We now collect like types. That will be, we have something like this. We have something like this. Collecting like times, 2 is common to both sides. We are having 2 into bracket log 3 minus log 2 all over log 3 minus log 2. What we are having in the numerator and the denominator is the same, so they cancel out. So what we are just left with is just 2 over 1, which is equals to 2, which is our final answer. Example number 5. Evaluate log 6 base 10 minus log 45 base 10 minus log 27 base 10. That is log 6 base 10 plus log 45 base 10 minus log 27 base 10. We are going to apply our log 1 and log number 2 of returning this to multiplication and then these two divisions. So we are having something like this. So log base 10 into bracket 6 times 45 divided by 27. If we should divide this by 3, we have 9. Divided by 3, we have 15. Okay, let's divide it by 9. If you divide this by 9 to be 3, we have 45 by 9 to be 5. And then 3 divided by 3 is 1, 6 divided by 3 is 2. So what we are having is 10. So our answer is equal to log 10 base 10. And from our log number 5, it says log 10 base 10 is equal to 1. So we can easily say that this our log 10 base 10 is equal to 1, which forms our final answer. Log 3 log A plus 5 log A minus 6 log A is equal to 64. What is A? That's our number 6 example. What we are going to do here is just that we are going to, it's just a straight addition and subtraction that is being involved. 3 plus 5, we have log A. On the left hand side we have log A, and on the right side we have log 64. So what we are going to do is just that we had 3 plus 5 minus 6. 3 plus 5 is 8. 8 minus 6 is 2. So we are having 2 log A, which is equal to log 64. So, which is the same thing as log A squared is equal to. Now, what value of 64? What factor of 64 will give us something like A squared? That will be log 8 squared. Now, we can just bring out our values. That is, A squared is equal to, that is, we can just neglect this our log term. So A squared is equal to 8 squared. From this expression, we can easily say that is, if we should find the square root of this and this, what will be left with will be, let's find the square root. Square root will be A square is equal to square root of 8 square. This square root will cancel this. It's just like 2 over 2. The number raised to power, just like if we say A raised to power 2 over 2 is the same thing as A raised to power 1. So what we are left with is A is equal to 8, which is our final answer. Example 7, 8, and 9 will be making use of the next example should be making use of our logarithm table. That is, it's expected of you to get your logarithm table with you so that you can solve these types of examples. Now we are example number 7. Use the logarithm table to find 215. Now what we are going to do is that for us to get our integer, that is our characteristics, that will be the number of figures that we are having here. This 1, 2, 3 minus 1. That's what? 2. That will be 2 points. Now we've gotten our integer. Now to get our mantissa, that is our decimal fraction, we now go to our logarithm table. Under table 1, logarithms of numbers. We now look at 21 under x. Under the column of x, you go to 21. Then you now go to 21 under 5. you check column 5, 21 under 5, that's 3324. 3324. With that, we've gotten the logarithm of 215, that is 215. Now, here we are having 4 figures. So that will be the number of figures minus 1. That will be 4 minus 1, that's 3 points. Here we'll be looking at 13 under 6, difference 4. Here we actually check 21 under 5. There's no fourth figure, so we are not checking for difference. But here we'll be adding the difference. The difference is to be added up to the values that we get under 6. Now go to 13 under x, that's 13, you under column x, you pick 13, you now trace it to column 6, that is the column that we now check it to 13 under 6, that's 13, 1335, difference 4. 13 under 6, that's difference 4. What we are having under 6, we are having 1335, difference 4, that's 13. You now add this 13. Under the difference, we have 13. You now add it. That will be 8, 4, 3, 1. So that's what we are going to have under our decimal fraction. That's what we are going to have under our decimal fraction, which is our mantissa. So that's 1348, which is the logarithm value of 1364. Now we now come to this. The numbers that we have